This question is to determine the number of its inflection points of a symmetric function. Consider the function y equals the square of the quantity x minus 1 times the square of the quantity x minus 3 star. How many inflection points does the graph of this function have? Options. First step is the symmetry insight. This function is symmetric with respect to the vertical line x equals 2. That means if there's any inflection point on the left of x equals 2, there must be another on the right. So the total number of inflection points has to be either 0 or 2, never 1 or 3. A common mistake is assuming symmetry guarantees just one inflection point at the center, but that's not true for this kind of curve. Next step is to first derivative analysis. Now we differentiate the function. The first derivative turns out to be a product of 3 terms. X minus 1 times x minus 2 times x minus 3, all multiplied by 4. This derivative tells us about the slope of the curve, but to find inflection points, we need to examine where the concavity changes. That means we need the second derivative. Next step is to using Rolle's theorem on the derivative. Let's look at the first derivative. It has 3 real roots at x equals 1, x equals 2, and x equals 3. According to Rolle's theorem, if a smooth function has equal values at the ends of an interval, then its derivative must be 0 somewhere in between. Applied here, this guarantees that the second derivative has at least 2 real roots, one between 1 and 2, and another between 2 and 3. That means the original curve changes concavity at 2 distinct x values. In other words, it has 2 inflection points. When the first derivative is a cubic with 3 distinct roots, the second derivative will usually have 2 real roots. That's your clue for spotting 2 inflection points, especially when the function is symmetric. That's it for this question solving. This video is based on our math tutoring blog and class recordings. Hope you enjoyed it. Please subscribe to our channel Math Tutor 8285 and turn on the notification bell. Press the like button. Thank you so much.